I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll briefly discuss about the topic enhanced information retrieval by RAG using generative AI. This is very important topic in the field of engineering and technology. It is a recent research topic. First, why is retrieval augmented generation RAG? RAG means retrieval augmented generation important. Generative AI Generative AI models, while powerful, often produce fluent but incorrect responses. This happens because they rely solely on the statistical patterns learned during training rather than grounding their answers in real time factual data. This problem is known as hallucination. The traditional information retrieval that we are calling it as IR systems, on the other hand, don't hallucinate but return a collection of documents matching the search terms. Users must then read through these documents to find the actual answers, which is inefficient and time consuming. And RAG merges these two approaches. It first retrieves relevant factual documents and then uses a generative model to produce coherent answers based on the evidence. This makes responses more accurate and grounded because RAGs uses evidence based reasoning, users can trust the output more. It is especially useful in domains like healthcare, legal research, or education where corrections is crucial. Mathematically, RAX expresses the probability of answers given a question as the weighted sum over the document answer probability. The equation is given by probability of answer given question is equal to summation of I probability of answer given document I comma questions into probability of document given questions. So we can express like this. This means the model considers both how likely a content is relevant to the question and how likely it is to contain uh, correct answers. Next, introduction to information retrieval and that is AI. Information retrieval, IR is like asking a librarian for help in finding information about a topic. The librarian returns books or documents that might contain the answer. However, traditional IR stops there. It does not exist, it does not extract or summarize the answer for the user. Users still have to search through the documents manually. And what the generative AI does is, in contrast, the generative AI creates human like responses, but without connection to real documents. It may fabricate facts. This is risky for critical applications. Therefore, we need a hybrid model that combines IR's factual grounding with the generative AI fluency. Next, we'll take one example, librarian example to understand RAG. Thinking of asking a librarian, what we are going to ask the question is to the librarian is who discovered penicillin? A traditional librarian, like a traditional IR, will find books or papers with the word penicillin and hand them to you, requiring you to search for the answer yourself. A generative AI based librarian might try to answer directly, but if it does not remember the correct information, it could give you a wrong answer like Louis Pasteur instead of Alexander Fleming. It will say like this. But the rack based librarian, here, the rack based librarian works smartly. It first retrieves documents that are likely to contain the correct answer, such as science articles that mention penicillin and Alexander Fleming. Then it reads and summarizes them, responding, Alexander Fleming discovered penicillin. This blends accuracy with fluency. Next, what is retrieval augmented? And also, here, what is a retrieval augmented generation? This we should understand well. RAG. RAG represents retrieval augmented generation. This means stands for retrieval augmented generation. RAG means it is a technique that retrieves documents from a knowledge base and then generates an answer based on those documents. This approach significantly reduces hallucination because the generative part is grounded in real factual documents. Mathematically, RAG represents the final answer's probability as the probability of answer given question is equal to summation of I to k into probability of answer given document I, comma question into probability of document I given question. This means RAG evaluates each document's relevance and contribution to the answer and combines them. It blends of search and summarization in one system. Next example question, that is, who discovered penicillin? The query. What is the query is, suppose you ask the model who discovered, model, the AI model, I'll be asking who discovered penicillin. A traditional IR system will return many documents containing the word penicillin without telling you which one contains the answer. A generative AI system might say something plausible sounding but incorrect. But a rack system will retrieve documents that mention Alexander Fleming. Correctly, it will answer us and the context of penicillin and then generate a clear, correct answer like Alexander Fleming discovered penicillin. This ensures correctness and fluency. Next, questions embedding. Before any documents can be retrieved, a rack transforms the user's question into a mathematical form called a vector embedding. This is a list of numbers that captures the semantic meaning of the question. For example, the question, who discovered the penicillin, might become phi of q is equal to 0.3, comma 0.6, comma 0.9, etc. This numeric form allows the system to perform similarity searches with the document embedding. It's how the AI understands and compass meanings, because the computer will understand only the numbers. Next, the step two is similarity calculation. So in this case, phi of q, you can write like this, no? So the step two is similarity calculation, and each document in the database also converted into a vector and using the same embedding method. For example, phi of the similarity is given by q comma di is equal to phi q into phi of di is equal to summation qj into tij, and it selects what it will do is it will select the top K document with the highest similarity. Who invented penicillin? It will searches from the rack and it will be giving us the highest similarity. The highest similarity we will be considering as the final answer. Next, step 3. So the embedding or essential for finding which documents are more relevant to the question. So for example, penicillin changes the mention. Penicillin was found during the bacterial research, like that. Next. So for example, in this case, so the document embedding, each document in the database is also converted into a vector. How how the vector using the same embedding method, for example, phi of d1, y of d2, y of the d3, etc. Say, for example, phi of d1 would be Alexander Fleming discovered penicillin in 1928. Phi of d2 would be penicillin was found during the bacterial research. Phi of d3, penicillin changed medicine, like that. These embeddings are essential for finding which documents are most relevant to the question vector. Next is step 3, generative candidate answers. Step 3 is the similarity calculation, and in this case, the next system calculates how similar each document. So here I missed it. The similarity calculation. Next, the system calculates how similar each document is to the question. This is done using the dot product between the question vector and each document vector. For each document di, this di, the similarity is given by phi of q into phi of di. Higher similarity scores indicates more relevant documents. The top k most similar documents are selected for next step. Next, generative candidate answer per document. For every retrieved document, the model tries to generate a possible answer based on the document and original question. For example, Alexander Fleming discovered penicillin, and penicillin was found during the bacterial research, and penicillin changed the medicine. Each of these candidate answered, and their query depends on how informative document is. Next, combined answer weighted by document relevance. The model then combines all the candidate answer, giving more weight to answers that comes from more relevant documents. Mathematically, the final answer probability is probability of y given y, the y given q is equal to summation of I to k, probability of y given q comma di into probability of di given y. This ensures that the most trustworthy sources contribute more to the final answer. And finally, the step 6 is output final fact based answer. After combining, what will happen is after combining the candidate answer, the model outputs the final answer. Since it's based on retrieved factual content, the result is highly reliable. For example, the final output could be Alexander Fleming discovered penicillin in 1928. This is more trustworthy than an answer generated by purely generative model without retrieval. Next, coming into the summary of RAC equations, so this slide summarizes the mathematical components of RAC. Phi of q is the vector representation of the question. Phi of di or the vector embedding of the documents. Similarity q of q comma di is equal to phi q into phi d. Dot product measures the relevance. Probability of yi given q comma di is the probability of answer given question and document. And the final answer is probability of y given q is equal to summation probability of y given q comma di into probability of di comma q. This equation defines how retrieval and generation works together mathematically. And coming into the conclusion, what are all the key takeaways from this sliders or the content or racks combine the strengths of research, that is a strength of research IR and generation to produce accurate and fluent and grounded answers. So that means rack combines the strengths of research and generation to produce accurate, fluent, and grounded answers. The librarian analogy makes it easy to understand. RAC first finds the right books, that is retrieval. Right books means retrieval, then reads and writes a summary, that means generation. By grounding the generative model in real documents, RAC minimizes the hallucination and increases answer reliability. through vector embeddings and similarity calculation, RAG makes AI responses more relevant and trustworthy. This, uh, this is especially important in AI applications like chatbot, search engines, and digital assistants. For instance, asking who discovered penicillin gets a trustworthy answer. Alexander Fleming discovered penicillin, sourced from real documents. So the retrieval augmented generation RAC. RAC means what? Retrieval augmented generation. RAC is a cutting edge research development in the field of engineering and technology, particularly within artificial intelligence and information retrieval systems. It addresses a key limitations of generative AI models, the tendency to produce factually incorrect or hallucinated content by integrating real-time document retrieval into generation process. This hybrid approach ensures that responses are both fluent and grounded in verified information, improving accuracy and trustworthiness. RAG has significant implications for applications such as intelligent search engines, virtual assistants, and AI-driven educational and medical tools, making it a transformative advancement in the pursuit of reliable, explainable, and context-aware AI system. Hope everyone understood about this interesting topic. The remaining things we will discuss in the next lecture. Thank you.